All right. Well, so we're going to start again, and this is the third video talking about the parameters. I went through these first four, and we're going to move on now to acceleration enrichment. There's a few different ways you can set up, we'll call it AE for short. And the one that seems to work the best on the turbo Buicks is the Excel pump AE method. There is another method in there, but I found it just doesn't seem to work very well, or maybe it's just very difficult to set up. And there are some other more elaborate ways to set up AE, but we're not going to go over these right now because the Excel pump method seems to work very well. All right, here are the Excel enrichment or AE settings. There's two kinds of AE. There's one that's based on throttle movement on this side, and there's one that's based on changes in manifold pressure. For the most part, I only use the throttle position AE, so I'll go over that one. But the map AE operates the same way. In other words, a change occurs and a certain amount of fuel is squirted based on that change. So we call this TPS dot, and in other words, a change in TPS over time, or a delta over time. And these bottom numbers are in percent per second. So on the positive, you see these are negative numbers, and here's positive numbers. So these are when you're pressing on the gas and how quickly you're pressing on the gas, how far the throttle moves per second, in a percent per second. And so like a small throttle movement might be just this first setting here. So when the car's running, you'll see like a little dot here. And when you press on the gas, you'll see the dot move up in correlation to where your foot is at. And it's not really in correlation to where your foot is actually at, but it's how fast your foot moved. We'll put it that way, how fast the throttle was pressed. And so if you move it a little bit, it'll get into this range. You move it a little bit more, it'll be in this range. And if you press it fast, very quickly, it'll get up into this range. And you can change the amount of fuel that gets squirted at these different times. I usually start doing this just in park, warm up the car, it's in park, and just blip the gas at different levels and hear, listen to what it sounds like. Does it stumble? Any hiccups, things like that, and you can move these up or down to get it as smooth as possible. It's really kind of a trial and error kind of thing. Yes, you can look at the air-fuel ratio while you're doing it, but don't put your full faith in that reading while you're doing AE. It's mainly about feel and sound and things like that. Down at the bottom, this setting here, the TPS dot threshold, that decides when AE will be enabled. How much throttle movement has to happen before you actually do give an extra squirt of fuel. There are very small throttle movements or even just noise on the TPS signal that you don't want AE fuel to happen. So we set this to a level that's just above, and that is noise or very tiny movements that we don't want AE. And if you set this too low, then AE fuel is going to be squirting all the time when it shouldn't be, and it'll get stumbling and weird stuff will happen. So this number down here, when the engine's very cold, it needs more AE fuel. So this is a multiplier that says when the engine's cold, add this much. This number actually applies at -40. So if the coolant was ever that cold, it would be multiplied by that much. Anywhere in between -40 and wherever the coolant is currently at, it automatically interpolates in between that. So it's not 190 the whole time. This section over here, it scales or basically multiplies the amount of AE depending on the RPM you're at. So below 2000 RPM, you get full AE, what you have it set on this table. If you get above 2000 RPM, it starts to scale downward as you approach 4000 RPM. And above 4000 RPM, there won't be any AE at all. Usually at the higher RPMs, you don't need that much AE. The air is moving very quickly through the motor, and you're not going to see much of a change in pressure when you press on the gas. So that's why you would scale it that way. This table here, it has to do with modeling the airflow through the engine based on how far open your throttle is. In other words, sometimes the amount of air going through the motor is the same at half throttle as it is at full throttle, especially if you're at low RPM. Let's say you're only at 1400 RPM. And currently the way I have this table set up is that it's about 40%, we'll say. This is telling the computer that if you're at 40% throttle, anything past that, no more air is going to go through the motor because it's a very low RPM. And the same thing as you go down. If the RPM is very, very low, not much more air is going to get through at these higher throttle openings. And I flatten this out at about 55% up here, and the reason I do that is just so it doesn't add any more AE above 55% throttle. Because when you've got the throttle open that far, and then you blip it a little bit more, the pressure change is very, very small, small enough that you probably don't need any AE at that point. So that's why I have it set up that way. You probably won't need to change this table. Okay, let's move on to boost. I'm not going to get into super detail on this video. I'm going to make a separate video just on boost control. These first settings basically have to do with just the basic setup, and this is set up as though you've got something close to a stock, a single solenoid like the stock car did. These settings here, the frequency range and the frequency itself, have to do with controlling that solenoid. You don't need to change that. With the ecu-gn, the boost solenoid wiring is connected to injector out I. That's what it's labeled as within the ECU. So just leave that on injector out I if you're going to be using the original connector out at the wastegate solenoid. These settings here, a minimum, that's the lowest possible duty cycle, the highest possible duty cycle. This is a coolant threshold for when it will start pulsing the wastegate solenoid. And right now this is set in closed loop mode, but I'm going to change it to open loop so it's more like the stock setup. I'm going to put this on off. So in open loop mode, you're just going to have this table. So based on wherever your foot is at, wherever the throttle's at, and what the RPM is, it's going to, in this case, on this table, it's going to be at 50% all the time. And in my car, that was about, and that's with a stock boost control solenoid, that was roughly 15 or 16 psi of boost that it would get up to, just leaving it at 50% all the time. Every car is going to be slightly different depending on how you had your wastegate rod set up with an internal gate, so this is the most basic way, and it's open loop, so there's no feedback. It doesn't look to see what the boost was. It's just this is what you get as far as the duty cycle. You can change that based on speed. You can change, if you turn this on, boost versus speed, and change that to VSS1, which is the mile per hour, the VSS sensor. And if the throttle position gets above 70%, now that I turn that on, another table appeared called boost control versus speed. And the bottom is the mile per hour, and the top here is the duty cycle. And so in this case, what would happen here is once I got the throttle above 70%, so if I floored it, instead of looking at this table, it will look at this table, and it would be 50% all the way up to 61 miles an hour, and then it would ramp down to 45% by the time it gets to 63 miles an hour. So maybe that dropped maybe 1 pound a boost or something like that. It's something you'd have to experiment with and see what works best on your car. A lot of people are going to want to use the closed loop boost control, so it actually looks at the boost and makes adjustments based on that. And I'll go over that in another video because it's a little bit more difficult. It's more time consuming to set up. We don't need to talk about anti-lag or variable valve timing. That's for other cars, so we'll just leave that alone. And we're not using these settings here. Okay, the table choices. This has to do with table switching. Now, what table switching is if you want to go to a different VE table or a different air-fuel ratio table based on some input. For example, let's say here's spark table switching. So if I turn that on and I go back here to the ignition settings, another ignition table will appear. Ignition table 1 was our original one where we set up our spark advance. 3 will appear, and then you can tell it under what conditions you want to change that other table. You can, for example, let's say I change this to hardware, and I could literally set this, just put a toggle switch and flip it on and go to another ignition table. Let's say you poured in some race fuel and you want to turn on a much hotter spark advance table or something like that. And but there's also other ways to do this. There's what's called a blend curve. So if I turn on that blend curve, that will appear here. And you can blend between the two tables, and this applies to any of these other, AFR or any of these. You can turn on these blend curves, and it gives you the option of switching between the two, in this case, ignition tables based on either throttle position, map, a flex fuel sensor, things like that. And so it's very configurable if you want to switch back and forth between different things. There's like on this side, this is turned off right now, but if I turn it on, some of the things will appear, like an alternate boost table. Let's say you wanted to turn on a different boost function. You could base that on E85 also, but that is also back here on the boost control settings. Boost table switching is also here, so you could turn that on and have it switch for different reasons. So that's table switching. That's just a neat way to change things based on some other input that you might set up. On the advanced engine menu, the top one is setting up your VSS sensor, and this will be set up for a stock VSS sensor if I set the tune up for you, unless you have something else. But that's right here, and the stock one was 2,000 pulses per mile. If you have taller or shorter tires, you might want to bump this up or down to get your mile per hour reading just right. If it's not the stock, 26-inch height. And now if you want to use traction control, then you would hook up another VSS sensor typically, and you would turn this one on and set it up for your other VSS2. And let's see what else here. This section down here, well, this whole thing has to do with gear detection. And the way we currently have it set up is to look at the third and fourth gear pressure switches, like from the stock that the stock car had, and it converts it to a voltage. And then we also look at mile per hour and convert that to a voltage to try and estimate what gear we're in. With the third and fourth gear pressure switches, we know where they're correct. The first and second gear, between those two, it's kind of an estimate, and it's mainly looking at wide open throttle, where it would have shifted at wide open throttle, which would typically be maybe 35 miles an hour, maybe 40, somewhere in that range. And that's how it estimates the gear. There's a lot of things here you are not using right now. I'm not going to go over everything. Generic sensor inputs. This is where you would set up extra inputs coming in, like fuel pressure, oil pressure, back pressure. And the first 5, I would just leave these alone because we're using these for other troubleshooting purposes, here, like wideband temperature and wideband volts and some other things. So you can add from number 6 on down, you can add things, and here's where you decide where you have it, where you tell the ECU where you wired it into, whether you wired it to some of the analog inputs or the CAN inputs, and then you can label what it is. This is fuel pressure in kPa, so that would have been connected to a fuel pressure sensor on the analog input 1, and this is how you set up what it will read. So we need to know what the sensor reads at 0 volts and what it reads at 5 volts, and you would plug that in here. In this case, it's kPa. This last box has to do with smoothing out the signal if it's pretty jumpy, and 100% means there's no smoothing at all, and the further down you go, the more it smooths it out. So that's this whole page has to do with setting up extra sensors. Okay, we're going to skip over some of those. Traction control. If you, as I mentioned earlier, if you connect a second VSS sensor, you can set up traction control. And here, once you turn this on, these other ones will appear. These other tables will appear about what you want to happen if it senses a slip, and whether you want to. Here's this retarding the timing. Here's cutting spark, but you wouldn't be able to do that with the stock ignition module. That would have to be like coil on plug or direct coil pack control or something like that. And here's cuts a boost. They're very configurable. There's a lot of different things you can do there, but that's traction control. Let's see, 2-step, 3-step. Now again, this kind of stuff, 2-step, 3-step, that is not, you can't use that with the stock ignition module or the TR6. The TR6 has a built-in 2-step, so you would adjust that inside the TR6 box. And now if you changed over to coil on plug or the direct coil pack control, then you can start playing around with the 2-step, because then it will directly control those items. Let's see, nitrous, water injection. I mean, you can control alcohol injection directly if you want to. If you enable it, here would be a table, how much to spray based on map and RPM. High power time enrichment, that is, if you turn that on, this can richen up the car over time. And that would be for a long, for an extended wide open throttle run. And here's seconds at the bottom, 5 seconds, 10 seconds. And it will just slowly start richening it up to kind of help cool down the combustion chamber. Setting up an oil pressure sensor, and also what to do if the oil pressure gets too low. You can have it shut the engine down, things like that. These down here are special outputs if you want to do some other things. Um, I'm trying to think of an example here. Maybe you have a secondary fuel pump that you want to turn on and off, and you would tell the computer what output you have it connected to. Um, in this case, it would you can this here's RPM. If the RPM is above whatever, or if there's like another condition you want to set up, you can turn it on and off. There's so many things you could set up this way. Another thing is pulse width modulated outputs. So if you wanted to, I don't know, maybe you had a seventh injector or something you wanted to pulse and spray, you could set that up, and just a lot of different things you can do there. All right, 3D tuning maps. Basically, that is just displaying the information. For example, that I clicked on VE table 1. Here's VE table 1. It's the same information. This is just showing you in a 3D form. It kind of shows you the shape of it and things like that. Do I tune off of this table? No, I don't. Normally, I use this table to tune from. But this can tell you if you did something wrong over here. And I'm going to type in, let's see, something way out there and hit enter. Oops, maybe burn. Oh, sorry, there we go. So you can see what happened over here. If I brought this table up and I saw this, I would know, oh crap, I did something wrong. Let me go back over here. And so I would put that back to wherever it was at, and then it'll come back correct. But yeah, that's all the 3D tuning maps are. It's just showing you things in a 3D form. Might help you smooth things out. But don't smooth things out just for the sake of smoothing things out. I mean, yeah, logically some things need to be smooth, but it's best to use data. This last menu has to do with a communications, a type of communication where we can connect other devices and communicate in high speed with the computer. At the moment, you won't really need to play with any of this. Check engine light. Here you can set up basically malfunction codes, for the map sensor, all the different sensors. And this is in basically digital numbers. For example, the map sensor 0 would be 0 volts, 1024 would be 5 volts. And so if it ever when you turn the key on, or if the engine's running and the map reading ever drops below that, then you'd get a check engine light. Fallback map table. If you do get a map malfunction code, this can fill in a backup map reading. And the main reason is to help you get home instead of just killing the engine. So I generally stick in some numbers here that will be on the rich side, just to make, if it's too lean, it may not run. So I go a little on the rich side to make sure that you can at least drive the car home. The test modes are very cool. It's almost too much to describe here, but let's see, injector. Here's a good one. In this mode, while the engine's running, I can turn each individual injector on and off. And so, for example, let's say you had a misfire, but you didn't know what cylinder it was. So you could turn on or off cylinder 1, then cylinder 2, then cylinder, and you could kind of listen to see if you get to a cylinder that doesn't make any difference, then you know that that's the problem cylinder. If you had individual spark control, you can do the same thing with that. There's testing modes you can go through. There's just things you can turn on and off Here's another way to turn injectors on and off. You can pulse them, and very it can be very helpful. Here's controlling the idle air control motor. You can force it to move to certain positions to make sure that it's working. The IAC. Engine control, stop engine. You can, if you click that, the engine, it'll shut it down. It'll turn the injectors off, and the spark. And reset ECU. That is, well, just like it says, it's similar to a power cycle. In other words, there's certain settings in here that if you change it, it needs you to power down the ECU for it to apply. You don't necessarily have to do that with the key. You could press, as long as the engine's not running, you can press the reset ECU button, and it's the same thing as powering it down with the key, and it'll apply whatever change you made. These are some very special stuff that we don't need to go over. You probably won't need to change that. And long-term trim. So this is, if you're familiar with the stock ECU, there was a BLM grid, and that was kind of equivalent to this. It's a long-term fuel trim. So when this is on, the reason why you see a bunch of weird numbers in here is because this table only will show you numbers if it's connected to the ECU. And so there's no good data in it right now because I'm not connected to an ECU. But you can set it to when it will monitor the correction, the ego correction over here, and or it'll display right here. And it will put that correction, it will slowly fill up this table. And so it's sort of like the long-term, like the BLMs on the stock computer, and it's sort of it's basically adapting to your conditions, and so that can be helpful. Some of the early tunes I left it on. I turned it off with most of the current tunes. I just figured I'd let the customer turn it on if they wanted to. Basically, you wouldn't turn this on until after you've tuned it. So once you got everything tuned in, then if you want to, you can turn it on, and then over time, with certain small changes, it will help keep everything, help keep your air-fuel ratio where you want it. And throttle can drive-by-wire, we don't have that. And I think that should be it for everything there. I'm going to go back and I'll make a video on boost control by itself, and I will probably make one on flex fuel. I've had some people ask about that, and I'm also going to do one on data logging. Great data logging, and how to make use of the adjustments in there. So that is it. I'll talk to you later.